Hi students, good morning everyone. So I hope all of you fine. And on previous class we discussed about acids. So what is acid? How does acids are formed? And how they are? So how can you test? What are the indicators? What are the metals? How they react with metals? What will happen if they react with non-metals? And how does the acid is formed? These are all discussed. Yes. So small topic will be is pending in these topics will be there, and that is about what will happen if the acid react with metallic oxides. So metallic oxides. When they react with metallic oxide, what will happen? Okay. And what will happen if they react with their carbonates and bicarbonates? Okay. So what will happen? That we will discuss in this lesson. Okay. In the today. Okay. The acids which are react with metal release H2 gas. H2. Okay. So example. So Mg plus. Okay. Then plus HCl gives rise to ZnCl2 plus H. Okay, this is about metals. Okay. So what will happen if acids so react with metallic oxides. What will happen? Metallic oxides. Like take sodium, NaO, sodium oxide, or calcium oxide, NaO, CaO, or it will take. Okay, they form HCl gives rise to NaCl plus H2O. They form their salt plus water. Salt plus water is formed. Okay. So any non-metallic oxide which is react with the acids, they form their metallic salt plus water. Okay. If acids react with metallic hydroxides. Metallic hydroxides. What happens if they react with metallic hydroxides? What they release? What will happen? For example, metallic hydroxide like calcium hydroxide, CaOH taken twice, plus HCl plus H2SO4 gives rise to. Okay. So what will happen? CaSO4 calcium sulfate plus water. Form the water. They form salts. So calcium hydroxide plus water. So 2H2O is formed. Okay. So they form salt, metallic salt plus water is formed. So any metallic, this metal react with hydrochloric acid, they form their salt. Here salt plus, hydrochloric acid released. Here metallic oxides, metallic hydroxides, they react with them. Whatever happens, they are released with salt plus water is released. Okay. So next, if acids react with carbonates, with the metallic carbonates. So what will happen? Okay. So when they react with carbonates, okay, like calcium carbonate, sodium carbonate, magnesium carbonate, like that they react with carbonates. What will happen? Calcium carbonate. So what will happen? Okay. Take CaCO3 calcium carbonate, CaCO3 calcium carbonate is react with the So HCl. You can take HNO3 also, no problem. HNO with nitric acid, HCl, sulfuric acid, any type of acid we consider. So what they release? What they release? Okay. So they release calcium chloride, CaCl2, CaCl2 plus, so H2O plus they release carbon dioxide gas. Release carbon dioxide. So what happens here? They release CO2 gas. CO2. Okay. When they release CO2 gas, when they any acid which react with their carbonates, they release CO2 gas. Okay. So when the acids react with metal, they release H2 gas. When the acids react with metallic oxide, they release so water plus salt. Then when they react with the metallic hydroxides, they release so salt plus water release. When they react with the carbonates, they release this salt plus water plus carbon dioxide. Yes. Not only you can consider sodium carbon dioxide, Na2CO3 also we consider. So Na2CO3. So Na2CO3 plus we consider H2SO4 also. H2SO4. What they formed here? So Na2SO4. Na2SO4 plus H2O plus CO2 gas release. So sodium sulfate is formed. Okay, sodium sulfate. So there is carbon dioxide gas. So like that, any type of carbonate you can consider, any metallic carbonate which react with the acid, they release the carbon dioxide. Okay, metallic hydroxides as NaCO3 also sodium bicarbonate and carbonates. So bicarbonates and carbonates. Okay, sodium carbonate to CO3, or we can consider NaCO3. Sodium carbonate, sodium bicarbonate. So anything which is reacting with the acid, they release salt plus water plus carbon dioxide will be released. So this is about acids. Okay. So where do we are using acids? So different types of acids we are in different purpose. Sulfuric acid. So used for manufacturing fertilizers. Manufacturing of fertilizers, and also which used in acid in car batteries. Vehicles in car batteries also we are used sulfuric acid. So hydrochloric acid used to form a starch from glucose. So to prepare glucose we are using, and also this acid used in dyeing industry, color industry. Okay. So and also these acids are used. Nitric acid used for to purification of gold and fertilizers also. Phosphoric acid also used for phosphoric fertilizers. Okay. Carbonic acid used in making of soft drinks. Okay. So acetic acid is used in to protect food articles. Okay. So like that we are using, and tartaric acid used for making of baking powder. So each and every acid we are using so many number of uses in our daily life we are using. Okay, this is about acid topic. Okay, about acids. Okay. So what is acid? What are types of acids? So where we are getting acids? How can you prepare the acid? How can you prepare the acid? Their physical and chemical properties. So and they are the chemical properties and the uses of acids. Okay. Okay, student, next basis. So basis. So already acids means they will express ions in the resultant water. Okay. So the basis which will be released a substance which so dissolve in water. Dissolves in water, release OH minus ions or bases. Okay. So and also the acids which are react with a substance, acids which which turn react with a chemical substance to form salt and water. So salt and water, that chemical substance is called base. So when acid is react with base, form salt and salt plus water. Salt plus water is formed. So acid plus base gives salt plus water. Okay. So the acid which is react with base, any acid which react any substance which is form salt and water, that substance is called as base. Okay. So the base, what are the physical properties of bases? How can you identify the base? So bases can be identified that they are slippery in nature. They are bitter to taste. They are bitter to taste. So bases are bitter in taste. Bitter in taste. So bitter in taste. Okay. And they are slippery to touch. They are slippery to touch. Slippery in nature, soapy to touch. They are smooth. They are very smooth. For example, you are using soap. So how the soap, when you touch the soap, it is very smooth, easily skip from our hands. Okay, usually slipping. They are slippery in nature. Okay, and when you test by using indicators like so they turn red litmus to blue. So they turn red litmus to blue color. So red litmus to blue. Okay. So blue litmus. So acids they turn blue to red here. So red to blue. Okay. So and so they change methyl orange. So yellow. To yellow. And naphthalene, phenolphthalein. Phenolphthalein. So pink. So they change phenolphthalein to pink. Some of the bases are they are very stronger. They can also cause blisters and harmful to the human beings. Okay. So bases are bitter in taste. They are very slippery in nature and soapy touch. Red litmus turns to blue. Methyl orange solution to yellow color and phenolphthalein to pink color. So you have in first activity one, you know all of the activity one. So in textbook activity one explains you. We have to consider, we have to take some of the acids and bases. Some of the acids and bases collect, like nitric acid, sulfuric acid, hydrochloric acid, some ammonium hydroxide, calcium hydroxide, potassium hydroxide. Like that, some of the bases and some of the acids consider, and you can take that in a test tubes and you can add these indicators. So methyl orange, litmus, you can add to them. Then how they are changed. So we can note down in a table. Okay, so acids how they are changing. So how the acids means how they change red litmus to blue, and bases they can change red to blue, acid they can blue to red, and how they change how it is affected naphthalene, how it is affected methyl orange. That is the table. You can fill the table. Every student, so go to the textbook and first activity do yourself. They will have given acids and bases. You can fill the table. Okay, so here. So bases better to taste, they are slippery in nature, red litmus to blue, they change methyl orange to yellow, phenolphthalein to pink. Okay, students. So next, so how does the bases are formed? How can you make a basis to form? So how does the bases are formed? How can we make a basis? The basis are formation of basis, preparation of basis, preparation of basis. Preparation of basis. Okay. So basis can be prepared. Basis can be prepared. So by the non-metals which are reacted, non-metals which are reacted with so water, non-metallic oxides which react with water, they form acids. But bases are formed metals which are burned in the presence of oxygen, they form the metallic oxides. These metallic oxides have the nature of bases. Okay. So the metals which are burned in the presence of oxygen, so form metallic oxides. So these metallic oxides have the basic in nature. So metallic oxides have basic nature. Basic in nature. Okay. For example, so Mg, Na, so Ca, what are you take? Mg, so plus O2 gives rise to MgO. Okay. So this MgO, magnesium oxide, okay. So having, okay. So this magnesium oxide is a base. Okay, base. So these oxides, for example, NaO, sodium oxide, calcium oxide, magnesium oxide, these are bases. Basic. Okay, metallic oxides they have basic in nature. Whenever the metallic oxides dissolves in water, when metallic oxides, these metallic oxides which dissolves in water, they form their hydroxide, sodium hydroxide. Okay, so NaOH. So this NaOH contains this also base. So when the metallic oxide which dissolves in water, they form their hydroxides. These hydroxides are also called as bases or alkalis. Okay. So whenever the metallic oxides, the base which are dissolve in water form alkalis. Okay. So base which dissolves in water, they form alkali. Alkalis, all bases are alkalis, but all alkalis are not bases. Okay. So sodium and metallic oxides means metallic oxides and metallic hydroxides. Metallic hydroxides are bases. Are called bases. Metallic oxides, metallic hydroxides, both they are basic in nature. So all metallic oxides are bases. So but all alkalis are not bases. Okay. So the metals which are burned in the presence of oxygen, they form metallic oxides. These metallic oxides have the basic in nature. So metallic hydroxides, so also the basis means the metallic oxides dissolves in water, they form their hydroxides. Hydroxides also have the basic in nature. So these basic in nature, their hydroxides are called as alkalis. Which dissolves in water, they are called as alkalis. Okay. So potassium hydroxide, there some of the strong acids are there, some of the weak acids are there. Like acids, they have bases of strong base and weak base will be there. Okay. So the bases which will be strong are the base which will be weak. So more number of OH minus ions which is present, they are called as strong. So base which are having less number of OH minus ions will be released, they are called as weak bases. So strong base examples are NaOH and KOH are the example for strong base. Strong base. So weak base, NH4OH, ammonium hydroxide, magnesium hydroxide, calcium hydroxide are example for weak base. Okay, so they are weak bases. Okay, you know all of you. So and sodium hydroxide, ammonium hydroxide, potassium hydroxide. So we are using so many purposes. Okay, so sodium hydroxide and potassium hydroxide used for making of soap. Okay, and also making a bleaching powder. Whitewash we are using for these sodium hydroxide and potassium hydroxide. And also this magnesium hydroxide, MgOH taken twice, used for antacid. So this is called milk of magnesia. This milk of magnesia is for antacid. So small kids, when they are getting the stomach pain, we can use this milk of magnesia to recover the stomach, to decrease the stomach pain. So ammonium hydroxide used as a window cleaner. So window cleaner. So windows you can use to clean by ammonium hydroxide. So potassium hydroxide, ammonium hydroxide, calcium hydroxide. So lime water, it is called lime water. So lime water used to make whitewash. Okay, so whitewash and bleaching powder can be made by using this. So calcium hydroxide, lime water. So this calcium hydroxide, ammonium hydroxide, magnesium hydroxide, so potassium hydroxide, calcium hydroxide, aluminum hydroxide. These are all used for the alcohol as a basis, and we are using different purpose. Making of soap, okay, and also making of fibers. So making of soap, making of fibers, so making of fertilizers. So for this purpose we are using this NaOH and KOH. It is used for lime water and whitewash, bleaching powder. So like that purpose we are using calcium lime. So this also quicklime, calcium oxide, quicklime to decrease the acidity of soil. We can use to decrease the acidity of soil. Use calcium oxide. Ammonium hydroxide clean windows, and magnesium hydroxide is antacids. Aluminum hydroxide and magnesium hydroxide for milk of magnesia antacids we are using. Okay, this basis. Okay, students. So in your textbook, first activity 1 to identify the different types of acids and bases. Okay, the table you can fill the table. Okay, activity 1. Activity 2, you can olfactory indicators. Olfactory indicator means what? So some of the substances which can change their order. It can change their order in different substances. In acids and bases, in acids they have one character only it is having. In bases it is having the another character. So it is called olfactory indicators. So activity 2 will be explained about take some onions. So in a cloth, okay, keep inside the deep freeze. After that, sometimes you can take out and you can take some of the 2 or 3 pieces of onions. So we can add and HCl, hydrochloric acid, so some pieces, and check it. What is the order? Again, or sometimes you can add sodium hydroxide to it. Or the order will be changed or will be same. Check it. Like that, we can clove oil, clove oil, and also vanilla essence. So these three items you can check by placing HCl drops on it. After check it by sodium hydroxide. We observe that the order will be changes in acid and base. So the indicators which will be changed its order based on the acids and bases, they are called as olfactory indicators. That is activity 2. Activity 1, activity 2. So activity 3, which I already explained you. So how does these acids and bases which react with how does the acid react with if the acid react with metals, what will happens? Okay, so when the acid react with metal, they release hydrogen gas, already we explained you. And also bases which react with metals, what happens? So when the bases which react with metals, they also only this zinc, only sodium hydroxide. So Zn NH4O. So what is the base to consider? So only the ammonium hydroxide having the capability which react with the metal zinc, they form zinconite, and plus the hydrogen gas will be released. So both the cases, activity 3, we can consider the acid which react with the metal, they release hydrogen gas, and also the non-metal means the base which react with the metal also release the hydrogen gas. That is activity 3, about activity 3. Okay, so we have the next activity 4 about when the carbonates, sodium carbonate, sodium bicarbonate, which are react with the acids, what they form. If they react with the bases, what they form. If they react with the acids, they release carbon dioxide gas. So Na2CO3 plus HCl gives us to NaCl plus H2O plus CO2. So they release. What happens? They release carbon dioxide. This carbon dioxide gas is react with water. What they form? Calcium hydroxide. So this calcium hydroxide react with the calcium carbonate. They form calcium. So CaCO3, calcium carbonate is released. So these carbonates will be released again. This non-metal means bases. What happens? The bases which react with the carbonates, what they form? They are formed. So calcium, for example, I will tell you. So this is about the uses of bases. Okay, students, in textbook activity 1. Activity 1 explains, considers some of the acids. So acids like, take acids like HCl, H2SO4 and HNO3, etc. And bases like calcium hydroxide, magnesium hydroxide, NaOH, KOH, etc. Okay, so they give a table for you. So in the table we consider these acids and bases like, so material, chemical, substance. So we consider some substances. First activity 1. So HCl, H2SO4, HNO3. So and calcium hydroxide. So potassium hydroxide, sodium hydroxide, potassium hydroxide, magnesium hydroxide, like that they given some of the acids and some of the bases. Here we have red litmus, blue litmus, methyl orange, and phenolphthalein. from same solution. So like that they given table. Yes, friends, you observe. So what happens if the HCl is react with if you take these solutions in a different four test tubes. Take 4 test tubes. Take 4 test tubes. Okay. In 4 test tubes. In 4 test tubes, you can add so a drop of HCl. So in that 1 drop HCl, add HCl, add HCl, add HCl drops. Okay, how it is changed? So red rate must change to no changes, no change. Okay, here blue will change to red color. Blue will change to red color. Methyl orange will be changed to pink, and naphthalene no change. Naphthalene will be no change. Like that, you can be do each and everything. So no and red. Okay, so pink, and here so no. Okay, so first these 3 will be same. Next calcium hydroxide it change to blue and no change. No, and here methyl orange change to pink or yellow and it will be pink. So it will be same. It will be same. So like that you can write. So this is the first activity 1 about in your lesson. Activity 2 will be same. So go through all of you. So go through the activity 1, 2, 3 and 4. Okay, this will be based on these topics will be there. So activity 1, this is activity 1. So activity 2 will be explains to you about olive oil, clove oil and so vanilla essence. So how they are affected, if they are change the order or not. If they change the order, then they are called olfactory indicators. So they not change the order, they are not olfactory indicators. Next activity 3 about zinc and HCl, zinc chloride plus H2 gas release. Metal react with acid, they release H2 gas. Non-metal also release with H2. Metals react with bases also release H2 gas. Fourth one, so what happens if the bases and salt react with the sodium carbonates? What will happen if they react with carbonates? So release carbon dioxide gas. So this is about for you. All of you go through the lesson and learn 1 to 4 activities. Okay. So all students. So homework is learn. So 1 activity 1, 2 activity 4. So all of you learn activity 1 to 4. Okay. So learn or write. Write in CW. Activity 1 to activity 4.